Let us go over the trick bite. So for number 1, you needed to solve. This should look familiar to you as we just tested on this. You needed to distribute the -7. Combine like terms on the same side if you had any. So on this left side, we can combine -16 and -21. And then once you get to this step, you have choices. What do you want to move? Or what did you move? Go ahead, Javier.
2x.
2x. So I would add this to the other side. And then move 37 to the right. And then divide it. So x equals -5. What's the final answer for that one?
X equals 5.
Unless it's 6. Double check my math. Okay. 4 is 48. Yeah, it'd be 5. Yes. But if you move the 14, you'd end up with a +12 on this side. And then you have to subtract 23, so it would just look the opposite. Like this. You would still get -5. It would just be opposite. For number 2, you needed to evaluate this, and you were given 2 different variables. So put -7 in, minus your 2. -7 minus 2 is -9. Remember that with absolute value signs, not with expressions. I'm sorry, not when we're solving. This is just an expression we're evaluating. And we can make everything in here positive. And that becomes a +36. For number 3, what was the domain of this? All real numbers. And remember, you need to have your set builder notation, so that's the curly bracket, your X, your line, X, your weird E, your R. When we get into the inequalities unit, we'll talk about another type of notation that we could do domain and range in, and that'll be interval notation. But we have some time before we get there. Number 4, we needed to find the value if f of x equals 10, and they give us an equation. Is this y or is this x? It's y. We have to find the value of x. So we're going to put 10 in for y and solve for x. Or you could have used your calculator and that was fine. So subtract 10 on both sides. And then get rid of the 1/2 by multiplying by the reciprocal. The 1/2 and the 2 cancel. You're just left with 0. So x is 0 when y is 10. You could put that back in and check. If I put 0 in for x, this becomes 0. 0 for 10 is 10. And then for the last one, you needed to use a distributive property to simplify. So this would be negative 5x plus 45. Questions on any of this? So we're going to start our first set of notes for this unit, intercepts, which I do not have open. Finding intercepts should be familiar to you, but maybe some aspects that we're going to go over might be new-ish. So first, let's start with definition of intercepts. Graphically, it's where your line touches your x-axis or y-axis. I'll say touches, crosses, or intersects. So if you have a line or a function or something that's even not a function, somewhere on a graph and it crosses the x or y axis, wherever it crosses it, touches it, or intersects it would be an x or y intercept. Algebraically, it's a little bit different. If we're finding an x-intercept, it's where our y value is 0. So we would put 0 in for y, solve for x. For our y-intercept is the opposite. So where our x value equals 0. So we would put 0 in for x and solve for y. So this is kind of like when we were, doing function notation, but just for when it touches the x or y axis. X-intercepts have different names. So these names are interchangeable. They are also called solutions, roots, zeros, and then of course x-intercepts. So solutions we've been dealing with a lot so far. Anytime we solve a problem, we get a type of solution. It makes the equation true. Roots is more for quadratic equations, so things that have this like U shape. But we'll deal more with the word roots when we get into the quadratic function. And then zeros is another word for x-intercepts because usually if you put it in, it makes it true and it zeroes out the rest. Anyone still need any of this? So there are a couple different ways we can find intercepts. One is from a graph. If you're given a graph and then you just find where it crosses or touches. One is algebraically, and then one is if it's a more complex equation, you can put it into like Desmos or your calculator to find the graph. So that's kind of still the same as the first, but a little different. Okay, let me know when you're finished. So for these, and some of you have already started it, and that's fine. We need to look and see where does this cross the x-axis, and where does this cross the y-axis. So where does this line, I like that one. This one right here cross the green or the yellow line, the x-axis. Look on your paper because it'll be easier to tell than mine. And you can say it out loud. So I would plot that point, and then to answer it, we're going to put it as ordered pairs, 2, 0. And then same thing, but now we're looking for where does this line cross the y-axis.
0, -2, or 9-ish.
Yeah, it's kind of not at, but we'll just assume it's a -3 for this one.
Okay.
Questions on how we found that? You just look at the graph, see where the line crosses the x or y axis, and you plot those points. Make sure you're writing them as ordered pairs. Sometimes you will have more than one x-intercept. If you have more than one y-intercept, it's not a function, but they're not really asking for that aspect. They're just trying to see, can you find x and y? So for number 2, again, look at your paper to see where does this cross your x-axis. It does. -2, 0, and not -2, 0.
-2 and 1. Or, those ones.
Does it cross it at -2?
I think it's different on the paper.
Yeah, on ours is -2. There's like -2.
Yeah, I don't know why. Okay. But yes, yours is at -2. I don't know why that's different. Okay. And then, so -2, 0, and 1. multiple x-intercepts, and that's okay. It just, if it crosses the x-axis multiple times, you just list them all. Yes.
So I would need 0 and 1.5.
I have to look at it. Yeah, we'll say it's like 0, 1.5. I feel like that's why I changed it to this one, but then it didn't print on that one. It's alright though. So if you were to get a graph that maybe is not exact, you could guess whatever decimal you want. As long as it's close, it's fine. And then can you hear which phone that is? If it goes off again, can you see if you can figure out which one that is? We're going to do one more together. And then I'm also going to add in an additional thing just to kind of go back and revisit some past material. For number 6, hopefully 6 is the same. Okay. Where does this cross your x-axis? And if drawing in the lines helps you kind of see those better, you can do that. Just tell me one of them.
-5, 0.
-5, 0 is one of them. Javier.
0, 0.
0, 0 is another.
-1, 0.
-1, 0.
Or -1, 2.
So that wouldn't be an intercept because it doesn't cross the x-axis. But 3 zeros would be. What would your y-intercept be here?
0, 0.
Sometimes your y-intercept and your x-intercept will be the same thing. It's okay if that happens. Really quickly, we're going to revisit our unit 2. Would number 1 be a function? Yes. Would number 2 be a function? Would number 6 be a function?
Yes.
Yes. So those would all be functions. Now, if I asked you what the domain of this is, what would that be? Correct. So somewhere where you have space, you could write it in here. We're just going to write that the domain is all real numbers. What would the range of this one be? All real numbers also. Yes.
Is it necessary to write that down every single time for the domain? If they just like that.
Say that question one more time.
So every time we do one of these, we have to write down the domain range.
No, I'm just revisiting past information so that it stays fresh. For number 2, what would the domain of this one be? Yeah. Assume that this keeps going. It doesn't have arrows, but assume that it does.
Wait, it's in what?
This one.
It does have arrows.
Oh, okay. For the range of this one, and I have to remember not to look at this one, but whatever you guys is.
Now, y is less than
1.6, 1.5, whatever decimal we use there, yeah. So it has a starting point but not a ending point, and it's everything below that. So y is less than or equal to 1.5, 1.6, whatever you put there. last one that we're doing domain and range on, and then I'll let you practice. For number 6, what would the domain of this one be? It does have arrows, it's weird, but this one is still all real numbers. What about your range?
All real numbers.
Yeah, because this is going to keep going down and up. Okay. The ones we did not do, 3, 4, and 5, I'm going to give you 5 minutes, and then I take that long to do those, and then we'll come back, we'll talk about them, and move on to the next. So for your Y-intercepts, if they're not exact, it's fine. Because again, that's why I changed it so that they would be exact on mine, but it didn't. It's fine. So for 3, 4, and 5, you should have had 2 X-intercepts. Number 3, you should have had 2 Y-intercepts. And if you put like a decimal, well, maybe yours was a little off. As long as it was close, that's fine. Eric, does that make sense?
Number 3 was really off on hers, so I didn't even write the second one.
For the Y-intercept,
Yeah.
still write it down because it does still have because it does still have 2 Y-intercepts. It just you can guess what that is. And then Abu, what were we saying?
What was the morning?
What was the Y-intercept?
What is morning?
-3.
That's -4.
What was this one?
Number 3.
Yeah, my graph is different than you guys' graph. So -4.1-ish and 3-ish. And then go on to the next page. It's not exactly that close, and it's not So we're going to find the X and the Y-intercepts for these. We're going to do a few together, and then I'll let you test them. For number 1, We're going to do the x-intercept first because that is the longest. So we need to set y or f of x to equal 0. Anytime we are looking for an x-intercept, our y value is 0. So like when we were finding function notation, if I said, this would be like a f of x equals 0 situation. So I would replace this completely with 0. And I would solve this for x. So f of x is just 0. Your y value is 0 anytime you have an x-intercept. So we would solve this like we would any other problem. If you need more space, you can either write on the back, the very last page, or you can get additional paper. Add 8 to both sides. And divide both sides by 4. So once you have solved it, you still need to put it back in your ordered pairs. So make sure this still says 2, 0. So anytime you're looking for an x-intercept, set your equation equal to 0 if it's in this format, and solve. So say that one more time. Anytime we have to look for an x-intercept, we set the y or the f of x equal to 0. That's how we can find it algebraically. Since our y was 0 and our ordered pair, that's where that 0 came from. Then we can find our y-intercept by setting x equal to 0. So if we were doing function notation, that'd be f of 0 equals. So I would put 0 in for x. I'm trying to find f of x. The 0 times 4 would just be 0. And 0 minus 8 would just be negative 8. Remember that f of x is the same thing as y. So this is saying my y-intercept is at negative 8. So I could write my ordered pair 0, negative 8. So for our y-intercept, when it's written in this format, f of x equals some number in front of the x and then a number without a variable, you don't really have to do work for that one, because whatever this number is going to be your y-intercept in this format every single time. Do you have any questions on that first one? We're going to do a couple more, starting with number 3, and then we'll do number 4. So for number 3, find our x-intercept, do the same process, put 0 in for f of x, and solve for x. Subtract 7 to both sides. What would I divide by to get x by itself? Negative 1. So that would be the ordered pair. How would I write that? 7, 0. In this case, remember that you could still do this work, put 0 in for your negative x or for your x. But whatever this is just going to become 0, leaving just the last number. So you don't have to keep doing that work. The next one we won't do that. So if you recognize it's in this format, you can just skip to the last step and say that your intercept is 0, 7. Questions on that one?
Can we see the line on an actual glass?
So can you see the line on what?
Like white on a glass. And like how
We will do that on the bottom, not for this part.
okay.
Okay, and then let's do one more of these. For number 4, find your x-intercept. The process starts the same. 0 equals 2 over 3x minus 6. Add 6 to both sides. And how would I get rid of 2/3?
Multiply 3.
Multiply this by its reciprocal, 3 over 2. Do that same thing on the other side. The 2/3 and the 3/2 cancel. What would 3 over 2 times 6 be? So your ordered pair would be 9, 0. What would your y-intercept be? 0, negative 6. Yes, thank you. How did we get what? So anytime it's in this format, which all of these are, you don't have to keep doing this work. If you recognize it's in this format, your y-intercept is going to be whatever this is. You just have to know it will be in this format. So you can just put your y is negative 6, your x has to be 0.
So that's 0 and negative 6 place. That's where it is right there on the bottom.
So like,
minus 6.
yeah, so if I actually put 0 in here, this would be 2/3 times 0 minus 6. 2/3 times 0 is still 0. 0 minus 6 is negative 6. So what you're doing is like skipping all of this work and jumping to that.
Yeah.
So the format would be y equals format 1 space.
And we'll get more into that when we talk about slope. Okay, any other questions on that one? I want you to do number 2, 5, and 6. I'll give you 5 to 10-ish minutes to do those 3, and then we'll come back and we'll do those. Let me know if you have any questions, need me to text something, or need my help. It's small, but I'm going to read out your x and y intercepts. and then we'll go from there. If we need to talk about how we found the answers to any of them, we'll go through that. So number 2, your x-intercept should have been negative 1, 0. Your y-intercept was 0, 2. Number 5, your x-intercept was negative 4, 0. Your y-intercept was 0, 2. For 6, your x-intercept was 10, 0, and your y-intercept was 0, 4. Do we have questions on any of those 3? Okay. For the next part, I'm going to show you how to do this in your calculator, how to do it in Desmos, and then I'll show you one last thing and we'll be done for the day. So, again, if you are using Desmos, none of these steps on the side you need to follow, but all the steps for your calculator are on the side of this. So we're going to start with number 1. We're going to put number 1 into our calculator. So go into y equals on your calculator. Actually, first, reset it. Second plus 712. That way, nothing else is in there, and we don't have to worry about other people's data and stuff like that. After you reset it, then go into y equals, which is at the top of here. And you're going to put in the equation from number 1, x squared minus 16. You can either hit alpha x, or you can hit this button right here for your x. Once you have that in your y equals, you can hit graph. So the graph button is over here on the right.
So process was. What was the process again?
It's on your notes right here. Once you're on your graph, the optional step 3 is not really optional. To find your values, you would need to use step 3. So you're going to go into trace, but hit second and then trace. The word calc or CAC above trace is blue, so second and then trace. And depending on which one you want to find first, your x value or your y value would depend on this part. Your x value has more steps, so we'll do that part first just so you know how to do it. So if we're looking for our x values, we're looking for our zeros. Remember, that's another word for x-intercept. So go into number 2. You can hit the number 2 or scroll down to it. And you'll get something at the bottom that says left bound. It wants you to pick a number that is left of whatever number you're trying to find. Now, on this graph, I can easily see what my x-intercepts are. But if you want to be sure that it's not like a decimal, this would be why you do this. You can't do both of these at the same time. You have to do them separately. So if I'm looking for whatever number this is, I need a number that's left of this. So give me a number that would be left of this one. You guys all answer at the same time. Negative 5 would work. -4 wouldn't because it's right on the line.
-6.
-6 would also work as long as it's left of this number. -10 would work. It doesn't matter. So I'm going to put in -5. So I just type that in and then hit enter. When you put in that number, yours may not do the line, but this little, like a triangle or something will appear right here to show you that's your, you can think of it like a wall, that's where it starts. And then it wants the right bound of whatever number you're looking for, so something that's to the right of this, but not going past this. So something in between here. Someone give me a number there. -1 would work. I could do 0, 3. I could just do -3. It does not matter. Somewhere in there. After you have your left and your right bounds, you should see these two triangles. The lines may be there, they may not. But that's saying it wants you to look between those two lines to find your x-intercept. After you put in your right bound, it's going to give you the option to guess. That's if you want to like pinpoint where it is. You don't want to do that. You want the calculator to do the work. So you just hit enter again. And it tells you exactly what that x-intercept is. -4, 0.
Wait. So, like, how do you got that?
We're going to do the other 0 on this as well. So
Wait, so I'm not getting
where are you at right now?
I'm not gonna step there.
The left or the right?
Right.
Pick a number in between you. And then hit enter and enter again. Huh? We're going to do the same thing but for the side, so if you have another question, just ask. So I'm going to go back in to second trace because I can't do it again off that same screen. Go back into 0. Second trace, go back to 0. Now I want whatever this x-intercept or 0 is. So I'm going to pick a left bound of this number. Someone give me a left bound of that number. 2 would work, 1 would work, 3 would work, 0. All of these numbers in here does not pass this one. So I can put 2, hit enter. Then we need a right bound of this number. Someone give me something to the right of that. 5, 4, 6, all of those work. You're right, 4 would not work because it's on 4. 5 and 6 would work. You could do 4.1 if you want to be technical, but I wouldn't do exactly 4. Again, it wants us to guess. We don't want to do that. We want the calculator to do the work, so I'm going to hit enter again, and then it tells us that our other 0 is at 4, 0. And again, we can see that, but just to make sure, you could use that function. Do you have a question? And then we're going to find our y-intercept. So right now, our y-intercept is not visible on this graph. You could zoom out or move the graph, and then it would be. But without doing that, if I go back into second trace, I'm now going to look for the value. So this is going to look for a y value, or your y-intercept, when your x is a certain value. So I'm going to go into value. And we want our x to be 0. That way it can be a y-intercept. So I'm going to put in 0. and hit enter. When I put in 0, it tells me what that y value is. So I don't see this on my screen, but I know that my y-intercept is negative 16, 0.
Did you just do all this by hand?
Could you do it all by hand? Yes. For the ones that we did above, for these ones below, I haven't showed you how to solve those. There is a way to solve them, but we're not doing that today. So for those answers, you would write in all of your order pairs. 4, 0, negative 4, 0, 0, negative 16. The y-intercept you also could have found just by looking because it doesn't have an x value. But the x-intercept is not a possible way that you would have been able to do that algebraically unless you knew how to factor. Yes.
So we're gonna do this one right here.
We're going to do one more problem, and then you'll have a little bit of time to practice. One more of these problems, and I have one more thing to do. So, those of you that already have your computers up, you can use Desmos. If you don't have your computer up, don't worry about this right now. You can practice this later. I'm going to put number 2 into Desmos. You can put in the f of x or leave it off. 5x squared plus 1x minus 3. You may need to zoom in. I did. Thanks. Okay. I just want to zoom in just a little bit. Just like no. Okay. Okay. So you may need to move your graph so you can see the y-intercept. Once you click on this graph, there will be points that highlight. Those will be your x-intercepts, your y-intercept. If it has a lowest or highest point, it'll also show that, but you don't need that one. But Desmos will give you those points. Okay. So that's why there's like no steps on it. You just put it in, click it, and they show up. Yes. That would be easier than doing it on the calculator, yes. But if you would rather do it with a calculator, that's why I showed it to you. Okay? The very last thing I want to show you, somewhere where you have space, I want you to write this down. (3x minus 6y equals 18). Because some of the questions you'll get on the Delta Math / Khan Academy intercepts from an equation will be in this format. The process to solve it will still be the same. You're still going to put zeros in. So if we're looking for our x-intercept, our y value has to be 0. So we're going to put 0 in for y. And we could solve. So this would give us, this would just become 0. So really I could just write 3x equals 18 and divide both sides by 3. And then I would do the same thing for y. For my y-intercept, my x needs to be 0. So I will put 0 in for x. And I would solve for y. This would just give me 0. So I could divide both sides by -6 and get -3. So if you get a problem like this, you could work this out fully, like we just did. You can also skip steps. If you know for a fact and you remember that when you are solving for an x-intercept, you're putting 0 in for y, that would be the equivalent of this becoming 0 and it disappearing. So if I'm solving for an x-intercept here, I could skip right to this step and solve that. Same thing for your y-intercept. If you know you're solving for a y-intercept, you have to put 0 in for x. This would make this 0, it would disappear, so you could skip right to this step. You would still need to show me that you divided, but you could skip to this step if it's in this format. So, for the next 5 minutes, and then I'll let you get your phones, either work on the last part where you're putting the questions in the calculator, Desmos, or the calculator, finding those x and y-intercepts. Or if you have your computer out / want to get it out, you can work on the Khan Academy document.